Hi, and welcome to section 4.2. Today, we're going to have a couple different objectives. We're all talking about how we're going to design an experiment. Okay. Section 4.1 was how do you collect samples? Now we want to talk about experiments because data can also be collected and is frequently collected using experiments. So, as we're cruising through our notes, sorry, I was at the back. Here we go. So, an observational study is when the researcher observes individuals and measures variables of interest, but does not attempt to influence the responses. The subjects are not being modified. There is zero manipulation. Okay, no variables are being manipulated. So, polls, collecting data about graduates from a school, heights of teenagers, just filling in surveys, no manipulation whatsoever is going to be there. Okay. Whereas an experiment is when you have the researcher deliberately imposes a treatment on individuals in order to observe their responses. So, for example, using a treatment to improve hair growth, we can either call it can be called your explanatory or your independent variable. Okay, so both terms are interchangeable. You need to be comfortable with both. They're what normally would be on your x-axis if we're talking about a scatter plot, right? Your explanatory explains the response or your dependent. So your explanatory in this example would be your type of treatment. And does the type of treatment impact or change your hair growth? Okay, or the hair growth. When you're trying to understand, this is a real big deal. When you're trying to understand cause and effect, then really an experiment, a controlled experiment is the best way to figure out cause and effect. You can't determine cause and effect if it wasn't in a controlled experiment. Otherwise, it's just a relationship. They're just related to each other otherwise. Okay. Confounding, real big deal. Okay. Confounding occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. So let's go back to this type of this hair growth, okay? Confounding variables could be like you use another shampoo at the same time, and the other shampoo cancels what you just did, or genetics. You know, some people have really thick, gorgeous hair, and some people have really thin hair. Okay. Or some people's hair grows really, really fast because you're taking vitamins. And then some people, or something else, and other people's hair isn't. So, taking vitamins would be a confounding variable. Maybe that impacts the results without, we can't separate it from the study. All right. Or genetics would be a confounding variable, right? The type of hair that you naturally have, how fast it grows, would be there. Okay. If I talk about the number of years of education a worker has and Y being the worker's income, what would confounding variables be? So I already I meant to move this to the blank part, sorry. But where you live matters, right? Income, salaries are based on your geography as well. New York City salaries are very different than South Jersey salaries, are very different than the middle of nowhere salaries, right? There's all different kinds of salaries based on where you live. Another would be your parents' income or education level. Both of those could be confounding variables. Where your parents' income, that's going to impact how much education you get. All right. They're very related. Okay. Or your parents' educational levels, right, is proven statistically that when parents go to college more often, then their children also go to college. Whereas if parents don't go to college frequently, then the children, they're definitely related to each other. Okay. So confounding variables. Another example would be weight loss, right? If you are Weight Watchers is trying to figure out if their new plan is helping, and people are, in Weight Watchers, and we're trying to run an experiment of whether or not Weight Watchers helps them lose weight. Well, Weight Watchers is all about diet, right? So the confounding variables could be exercise. What kind of exercise are they doing on the side? What kind of medications are they on? What about their sleep habits? Sleep is related to weight loss and weight gain. Genetics and medical conditions, all that stuff would be confounding variables. All right. So, objective 6, we want to identify subjects, treatments, and variables in experiments. Okay, so when we're identifying these major terms, your treatment is your specific condition applied to the individuals in an experiment. The control group doesn't get the treatment. The treatment group gets the treatment. Your experimental units are the people or the individuals who get the treatment or not. Okay, if they're plants and we're trying to see if a new fertilizer helps plants grow, then the plants would be your experimental units. The fertilizer would be your treatment. Okay, your control group is your group that received the placebo or don't receive a treatment. Okay, so placebo pill would be like a fake pill. So people think that they're getting medication, but they're not. All right. In psychology, this is probably all coming back to you if you've taken psychology. A control group, right, is the group that gets a placebo. There is lots of research that shows that there have been people who respond to a placebo. They think they're taking medicine to help them cure an ailment. They're really not, but then the ailment starts getting better because they've convinced themselves psychologically that they're getting better, even though they're actually not taking medicine. We could spend hours talking about the placebo effect, but it's a really interesting phenomenon for any of you who are intrigued by psychology. This would be well worth your time to go check it out. So here you go. Example 2, I want you to read through this. A study published in the New England Journal of Medicine compared 2 medicines to treat lice, an oral medication called ivermectin, and then a topical lotion containing malathion. Researchers studied 812 people in 376 households in 7 areas around the world. Of the 185 households randomly assigned to ivermectin, 171 were free from head lice, compared to with only 151 of the 191 households randomly assigned to malathion. We want to identify the experimental units, your explanatory response variables, and the treatments in this group, in this experiment. So try that right now. Identify your experimental units and all these guys, and then unpause. So pause, do all the work, unpause, come back here. Okay, our explanatory units, or experimental units, sorry, are 376 households. Our explanatory variable are the types of medications. Your response is, did they still have lice or not? The treatments were the 2 medicines. In this case, there's no placebo, because if you don't treat lice, lice are not going to disappear. So sometimes you can't not treat it, right? So it was comparing the 2 treatments to see which treatment worked better, because if you don't treat lice are not going to disappear on their own. So that's something that they couldn't use a placebo for, because they already knew the results of that. It would be 0. All right. Now, when we talk about principles of experimental design, all right, it's when we want to use a design. Let me come over here. We want to use a design that compares 2 or more treatments, okay, or a treatment and a control, a placebo. We want to control the effects of lurking. Lurking variables are the same as confounding variables, essentially, on the response, most simply by comparing 2 or more treatments. Okay, you want to do as good of a job as you can to control confounding variables. You need to make sure that you always use randomization. If you don't randomly assign the subjects or the experimental units into the treatment and control, then your experiment has failed right from the beginning. Okay, you won't necessarily have people randomly in the study. You have to have people who are willing to participate. But then once they're participants, then you put them into treatment and control by randomization there. And you need to repeat. You need to replicate each treatment on many units to reduce chance variation in results. You need to repeat this study as many times as you can, because the more often you repeat it, the more accurate you're going to have results. Okay. When you do that, if your results are found to be statistically significant, which we're going to spend the whole second semester talking about if something is statistically significant or not. But when you find your results to be statistically significant, that's when an observed effect is so large that it wouldn't occur by chance. Okay, that it would rarely occur by chance. The difference is going to be so great between what we thought was going to happen and what did happen, right? Or the control and the treatment. It's such a big gap between the two that there's no way it happened by chance. It has to be statistically significant. So let's talk about a couple different types of design. All right. Number one, we want to identify and recognize the importance of completely randomized and block design in experiments. So completely randomized is when you have everybody together in one big pile and you just start splitting them up, random, 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 random. Okay, you're not looking at their traits when you do that. You just start dividing them into groups. For this first example, psychologists want to know how different types of television shows impact young children. They recruit 64-year-olds and have them watch 9 minutes of a fast-paced program, 9 minutes of a slow-paced program, or draw for 9 minutes. After the 9 minutes, each child will complete several tasks, including tests for mental ability and impulse control. Design a completely randomized experiment designed for this experiment. Write a few sentences describing how you would implement your design. Now, there are two methods to approaching this that are acceptable on the in the College Board's eyes, and my eyes too. One is to paragraph. Okay, you can just start by writing it out as a paragraph. The other way you can do this is with a flow chart or a tree drawing. Okay, I took my 60 children. I broke them into 3 groups. I'm randomly assigning. I really should write with a number generator or with a random digit table into 3 groups. Okay, this group is going to get my fast-paced show. This group is going to get my slow-paced show. This group is going to get drawing, the control. Then at the end, I'm going to compare all 3. I'm going to compare their mental ability and their impulse control. You should still then like write a sentence or 2 to summarize this. But I personally like this method better just because I think it's easier to see. I think sometimes paragraphs, you have a hard time breaking it down. So I like this because it gives me a flow of the graph, okay, or a flow of how this experiment is going to run. So I'm a fan of it looking like that, okay? But you should. I didn't have like a wrap-up sentence of how I would do that, and a wrap-up sentence would be beneficial. So completely randomized. I just took all 60 kids and I randomly split them up into 3 groups. You have to identify how you're going to randomly assign here, right, into the groups. Now, when you're doing experiments, you also can have single blind or double blind. Okay, if you're blinded in an experiment, that means you don't know part, right? So part of what's happening. So here, one party knows they're part of an experiment and the other party doesn't. It could be that the people don't know that they're in an experiment, but the experimenter knows. It could be that the experimenter doesn't know who's in the treatment and who's in the control. All right. Somebody else takes care of that for me. I'm the experimenter. I run all the numbers after the experiment, make a conclusion about group B or group A, and then find out if B or A, which one was the treatment and which one was the control. Double blind is when neither the subjects nor the people who have contact with them know which treatment a subject received. So when the experimenter doesn't know and the people don't know, that's when it's a double blind experiment. Blocking is really important and a super useful way to work through this. Okay, if you're blocking, all right, it's very similar to stratified. You're going to break the subjects into layers, and then you're going to, like, or in a similar traits, and then you're going to do a treatment and control for each layer. You can't call it stratified. Stratified is when it's an observational study. So if it's an experiment, you have to call it blocking. If it's an observation where you're just collecting a sample, then that's when you call it a stratified sample. So I love popcorn. I don't know about you guys. I love microwave popcorn, right? So popcorn lover wants to know if it's better to use the popcorn button on the microwave or to use the amount of time that's recommended on the bag, right? We're a fan of the popcorn button, but sometimes you burn your popcorn. or it's not done. So to measure how well each method works, she's going to count the number of unpopped kernels after popping that remain after popping. To obtain the experimental units, she goes to the store, she buys 10 bags, each of 4 different varieties of microwave popcorn. Okay. She's going to get butter, 10 bags of butter, 10 bags of cheese, 10 bags of natural, 10 bags of kettle corn. So we want to first explain why a randomized block design might be preferable to a completely randomized design. All right. Randomized block would mean that we're treating it by type: butter, treatment control; cheese, treatment control; natural, treatment control, right? The popcorn button or the time; kettle corn, the popcorn button or the appropriate time. As opposed to completely randomized is we're going to take all 40 bags, shove them in a box, randomly pick out 20, use the button, randomly pick out 20, use the correct time. So I had written it this way: a completely randomized design ignores the differences between the 4 types of popcorn. Randomized block will consider each variety of popcorn separately, which allows us to account for differences in type. Maybe cheese it works well and natural it doesn't. I don't know. Okay. Now, I want you guys to outline a randomized block experiment and describe how you carry it out, how you carry out the random assignment required by your design. So make sure you discuss the randomness. So pause it, try that in pencil on yours, and then come back. All right. I had here are my 4 types. This is a bit sloppy. I apologize. I should have done a nicer job of this. 10 bags here, 10 bags here, 10 bags, 10 bags here. Okay. Then I'm going to randomly assign them here. 5 get the button, 5 get the time. Randomly assign, 5 get the button, 5 get the time. I should put here with random assignment, like picking them out of a box. Okay, like randomly throw them all in a box, shake them up, pick 5 and 5, split them up. Then you're going to compare this type. You're going to compare here, then you're going to compare here, then you're going to compare here. Then you're going to compare all of those. So you have 2 layers of comparison. You have these that are being compared, but then you have all 4 of these that are being compared. Okay. So last one is a matched pair. Okay. Matched pairs design is when it matches subjects in ways that can produce more precise results than simple randomization. It's a special case of randomized block design that uses blocks of size 2. So blocks of size 2, we're going to pick examples like these. All right. It would be like when you're creating blocks by matching pairs of similar experimental units. One example would be measuring the strength of your dominant hand versus the strength of your non-dominant hand. Okay, how fast how strong is if you're a righty, how strong is your right versus how strong is your left. If you're a lefty, it should be vice versa. How strong is your left versus how strong is your right. Texting, right? You probably hold your phone in your dominant hand and text with that thumb. So we could say the speed of texting with your dominant hand versus the speed of texting with your non-dominant hand. Okay, and it could be like that could be your dominant and control would be your treat, and then control would be your other, or you know what I mean? Like you could compare them that way. So if there were 50 people, you'd have this type of table. Each person there'd be 50 of them. You'd have one of these for John, treatment control. You'd have one of these for Bob, treatment control. One of these for Sue, treatment control. One of these for Katie, treatment control. One of these for Angie, treatment control, and so forth. You'd have 50, if there were 50 people in the survey, in the experiment, you'd have 50 of these, and then you'd have treatment control for each one. All right. Another one would be your standing pulse rate versus your sitting pulse rate. When you're standing, your body is using more energy than when you're sitting. So compare them. Are they the same or are they not the same? All right. 50 people, you'd have 50 layers because each person, you would never compare my pulse rate to Sabrina's pulse rate. That doesn't make sense. Like my standing versus her sitting. It'd be my standing versus my sitting, compare them, and her standing versus her sitting, compare them. Okay. And then same with like our whole class. You wouldn't mix and match us. Each person would be their own branch. Okay. So your book does a really good job. You will see lots more of these types of problems as you do the practice. Remember, these practice problems are so important to do. Okay. And I will talk to you soon.